Okay guys, welcome back to the channel. In this video, we're going to discuss development programming. We're going to do this with Nick Mudge. And you're all watching this. Why? Because you want to become better blockchain developers. You want to build amazing dApps. So you subscribe, you smash the like and the bell button. But first and foremost, Nick, welcome to the show. Please explain to people who you are. I know you're quite big on Twitter, but if somebody doesn't follow you yet, give them a crash course into what you do.
All right, hi, yeah, so I'm Nick, and I'm a Solidity developer. I'm a smart contract standards author. I write and I build things. I've worked with the QuickSwap project. I wrote much of the smart contracts for Aavegochi, which is this DeFi and NFT project combined. And I've also wrote the standard for diamonds on Ethereum, which we're going to talk about.
Very, very good. So you've been building on Polygon, on Ethereum, and the good thing is that it's all EVM, so you can build on all kinds of blockchains. And that's really the first point I want to communicate to all of you guys who are watching. If you learn Ethereum programming, you can program anywhere, like Polygon, Binance Chain. And so please tell us about the different projects. Like, for example, QuickSwap, it's kind of like Uniswap. So what is the process of launching a Uniswap kind of DEX on another blockchain? Is it just that you copy-paste code? How much actually do you need to change? And what is the process?
Yeah, so for QuickSwap, it's a direct clone, exact clone of Uniswap on Polygon. So there's no code changes. You know for the contracts, you deploy them on Polygon, and then a lot of the work with QuickSwap is with the modifying the user interface. Right. And then we did add some other contract stuff to QuickSwap, like we have a token Quick, and it's possible to stake Quick to earn more Quick, and we have rewards for liquidity pools, things like that. So, but yeah.
Very nice. Mm-hmm. And Aavegochi, please tell us about that project, because there is Aave, but then you added some NFTs. So how does that work, and how did you expand on Aave?
Yeah, so with Aavegotchi, we created these NFTs of a ghost. And Aavegochi is a ghost, and it's like a gamified NFT project. And Aave itself means ghost in Finnish, and so we have this idea where, okay, let's have an NFT and let's be able to take Aave's A tokens, which are these interest-bearing tokens, and allow people to transfer them into the Aavegochi. And so then you have these NFTs that are increasing in value through these interest-bearing. Nice. Yeah, but it's also, Aavegochi's a game, so we've gamified it. We've created wearables, which are these wearables are like a hat or a grenade or like all kinds, and each one is an NFT. Well, it's a ERC 1155 item, and you can put them on your Aavegochi, and so we've integrated that on the contract level, so that an Aavegochi NFT, which is ERC 721, on the contract level actually owns these other wearables, and then the owner can remove them and add them and things like that.
Nice. And so when you look at something like Aavegochi and you have to add a bunch of NFT features to an existing project like Aave, and you can take these A tokens, you can lock them up into NFTs, things like that. What kind of work needs to be done in terms of the interface? Because, for example, in NFT standards, as far as I know, there is no way to list all owners of a token. I mean, you have balance off, but then you have to ask for each address. What kind of challenges do you have when you build something with NFTs and you want to build a front end? Is there something that you think about that is challenging?
Well, it's using a lot of indexing the events, and you really utilizing that with the events, so that there's a lot of infrastructure type work with that to do that. But also because it's on Polygon, it's also, and because it's using a diamond really allows you to add more functionality, and you're not limited by the contract max size, and so you're able to add you're more free to add functionality to your contract. So at the beginning, we would add more functions for the user interface to make it, to make some things easier for the user interface, and then because we could add functions for the to make the user interface easier, and then we got more into using the graph and using events and things.
Sounds good, because that's something that we notice a bunch of projects struggle with, that in order to even display all owners on an NFT, like you say, you have to index, you have to listen to smart contract events, you have to build an index of the owners, and that's a big problem. And also that's why we built Moralis, that you have a user, they log into your Dapp, you instantly have all balances of everything, because the way that smart contracts are built, the standards, I'm not too sure that they have been fully thought through. The fact that you cannot even get, like we just discussed, a lot of things without indexing them. So personally, I see this a lot in the way contracts are built, that it's basically an index is required. Is that something you think that developers didn't think it through enough when they did the standard? Because they could have just added a bunch of more features in the interface, functions in the interface, or was it a good decision to keep the standard as lean as possible, and then let the developers index and do everything on top using the events? How do you think that decision was?
Right. I think that for ERC 721 for owners and stuff, I think there was concern about not causing future problems, because if you have it in the standard, something return all owners for all, then you could hit limitations and being like, if you have 100,000 users, then this function or 100,000 owners, this function might not work for some applications, and so you have this standard function that doesn't work for some applications, and so in designing that standard, they had to think about the future and like, how will this, let's design this so that it will always work. There is, for ERC 721, there is an extension to it, the enumeration part of the standard, which is optional, but it allows you to return an owner one by one kind of thing, enumerate through it. So it's not like that great. So I think for again, for Aavegochi, I think we probably did add a function in there to return. Maybe we did for like all the owners. Like we added stuff to make things easier. One thing with Polygon is I've developed on Ethereum applications and Polygon, and one big difference that I found is that with Ethereum, and this is also true with the contract standards, is that you're also thinking with gas costs on Ethereum, because if you don't want to write smart contract functionality it's going to cost users too much to execute, so you're always thinking with that. But on Polygon, you don't have that problem, so because the gas price is so low, so you can add more contract stuff that integrates, or more code, more contract execution. It doesn't matter, so you're more free to add, again, more functionality,
right,
make things easier for executing transactions. So
yeah. Makes sense. So before we go into the Diamond standard, do you want to show some code, how you build, what kind of tools you use, or should we first talk about the Diamond and then go into the tools and actually take a look at some code?
I think we could talk about the Diamond first.
Let's do that.
Okay.
So now Nick will bring up the standard that he's working on for Ethereum smart contract upgradability, the way I understand it. But we're going to learn this together with Nick. So maybe start with the problem. What is the problem that this standard is trying to solve?
Right. So originally, the problem it solved is this max contract size limit. This is that when you're writing a contract, when you compile it, you have this bytecode, which is your contract, and you deploy it. But if the bytecode goes above 24.5 kilobytes, you can't deploy it. It has to be under that limit of that size, and so and that's fine. That size limit is fine for certain applications. You can, instead of having one big contract, you can break it up into smaller and have them call each other. But I found, like in my particular project, it was an NFT. I was creating an NFT with a lot of functionality, and I needed all my functionality in one contract because it was all related to the same NFT, and breaking it into multiple contracts was just, it didn't make sense. You have an NFT contract. It makes sense that your functionality for your NFT comes from the same contract, and so And so I deep dived into ways to solve this and spent 2 years doing it and experimenting and getting other projects using some solutions and getting feedback. And so then it developed into the diamond standard, and it solves it provides a way to overcome this limit. So you essentially have one contract that can have a practically unlimited amount of functionality. You can keep adding functions, and so that's like the first problem. But then it actually ended up solving some other problems, like if you want to upgrade, you can instead of having to redeploy everything with a new address, or or just having to redeploy everything, you could just deploy just the functionality, the new functionality you want, and add it to the diamond. Or so you could it's more fine grained. You can replace just the parts you want to replace. There's some caveats to that, but that's kind of it's been useful in experience to be able to do that.
So to summarize, number one is that the contract becomes smaller. You will explain how, but the way I understand is that you don't have this limit anymore. So somehow you make sure that this extra functionality doesn't take up as much space as it would if you just wrote it in the smart contract. And second one, as you say, is that you can replace portions of your smart contract, not the entire one, but you can replace the functionality portion by portion. And I guess that is somehow different from the proxy, because the way that many developers do upgradability now is that they have proxy contract. But that is like a whole new contract that you just link from the proxy. But here you basically can proxy the different functionalities, or how do you do that? The different portions?
Yeah, so your normal proxy contract has one implementation contract, and so when you upgrade, you just replace that implementation contract, right? So with a diamond, it's like you have multiple implementation. Diamond is a proxy, but it has multiple implementation contracts. In the diamond terminology, these are called facets, because a diamond has different sides or facets. So with the diamond, you have multiple implementations. And so if you want multiple implementation contracts, so if you want new functionality, you just add another implementation contract, and you don't have to touch the ones that exist already. Or if you or there's functionality, you say you have a function and you want to change it somehow, as a bug, or you want to improve it, you just replace that one implementation contract with
Makes
a new
sense. So a smart contract built in this way is really a collection of different smart contracts, but they're glued together through these proxies. And that you can have basically you divide the smart contract into many smart contracts, but you can think on a higher level about them as like one smart contract, and then on the lower level it's broken up into all of these sub smart contracts. And I guess the problem is that it becomes complicated. You need to keep track. Okay, this one I put there, that one I put there. So do you have what would be good, and let me know if you agree, is if there is some kind of addition to Solidity, where you can write that, okay, this is like one faucet, or did you call that like it's a faucet, or what is the different functions called?
Yeah, so each implementation contract is called a faucet.
Got it. So how do we easily coordinate all of that? Because let's say I have like 100 different faucets. Is it a file for each, or how do I do that?
That's a great question. So I found that makes the most sense from people can try to do things different ways, but what I found that works really nicely is that you take functions that are related or similar that go together, you put them in their own faucet. And so like as an example with Aavegochi, the Aavegochi diamond, Aavegotchis themselves are an ERC721 token. And so I created an Aavegochi faucet that has all the ERC721 functions, because those functions go together. So that's one faucet. So, right. And then as I mentioned, we have ERC1155 tokens, which are the wearables. Well, all those functions go together. So I created a faucet for the items, or the wearables faucet. And so so basically for your project, for your contract, for your diamond, you just logically organize, put related functionality together each in their own faucet, and you organize it and structure it that way. And that's actually another thing that I found really useful with the diamonds, that I wasn't trying to do, but it just naturally fell into place, is that it provides an organizational structure for functionality, which is really needed when you have a lot of functionality. And then if you go, if projects can, you can go from diamond to diamond, it's all organized the same way, which I think is useful.
Right. But so what defines the standard? Because what is the difference of doing a diamond versus just doing a bunch of different smart contracts linked together, like you described in the beginning? That today developers, to avoid this limitation in size, they just break up the contract in many contracts. And maybe they already today link the same functionality. They put the same functionality into the same contract. So what defines the standard that makes it different from just, normal thinking of breaking up contracts?
Yeah, so what really makes it a standard and useful as a standard is the interoperability, the tooling and interoperability it provides. Like let me give you an example. There's a lot of examples, but one example is, let's say that you want to the diamond provides a way to introspect it, to be able to see like what faucets does it have and what functions does it have. And that's part of the standard. That's standardized. So you could create a user interface that you put in the diamond address, and then the user interface says, "Oh, okay, here's the faucet addresses, here's the functions, here's the names of the functions," and nice. And that'll work with any diamond that works with the standard. So that's one example. Another example is that when you do an upgrade in a diamond, there's an event. It's the diamond cut event. So this event, it's a standardized event. So again, you can build tooling for that, build one tool, and then using that tool, you can provide all the upgrade information for any diamond. So that's another example. There's a diamond, there's a upgrade function. It's called the diamond cut function, and again, it's standardized. So again, any tooling can call the same function on diamonds, and be able to upgrade diamonds. So it just provides this interoperability so that diamonds can work across tools. Yeah.
Yeah. And I mean, is there any reason to do something for truffle? I'm thinking that you as a developer, you don't even think in terms of different smart contracts. You as a developer in an ideal world, you would just be writing your own, your smart contract the way you would be doing like any other application. So you don't really count, how many bytes you have now, and oh, now I'm over the limit, so I better now, split it up. Does that make sense that we build some kind of tool to truffle or something, or any other framework which would kind of divide this into and upload and manage? So does that make sense, or is easy as is? Would you say?
Oh, something that sort of automates helps automate the creating the faucets of the diamond, or something like that.
Yeah, exactly. Something like uploading and linking them all together. Mm-hmm. And maybe it's not needed. You tell me. Maybe it's easy as is. But I'm thinking, for me as a developer to learn like all how it works, it would be nice if it just worked from truffle. Am I thinking correct, or you think that it's easy as is?
I think both. I think that the standard itself is once you understand it, it's just to do an upgrade using the standard, to deploy it. It's pretty easy just using existing tools. Once I say once you understand it, because some people have trouble the conceptual conceiving it, but it's really it's just function calls. You don't have to go too much into low level stuff, or things that are outside what a Solidity developer does for deploying, for upgrading. But I do think that, but at the same time, I do think there is like, one, you have to understand how some of these things work, and you have to write the code for it, and it doesn't really make sense for every developer to have to write the same code to do deployment, to do upgrades, to do some of the testing. So I think tooling is definitely useful here in saving time, and bringing developers up to speed, or making it useful to developers faster, because they don't have to learn everything at once. So tooling, I think, is very important here. There has been some tooling on Hardhat. Has a plugin. It's the Hardhat deploy plugin that provides support for diamonds for deploying them, makes it easier to connect to things and so on. And so I don't think there's something for truffle, but I think that would be really great if someone built something and built other toolings. I started a library, I think it was like diamond.js, that helped with deployment upgrades. I kind of abandoned it. One reason is it was pretty easy for me to just use like the standard directly, and I just didn't have time to make it the diamond.js like really like production or polished and stuff. But I think it's still a good idea.
Yeah, I think the standard makes perfect sense. I mean, one thing is maybe it would be nice to maybe call it a bit different, because diamond you really need to wrap your hand up why it's a diamond, the different phases. But in reality, it's a kind of function level proxies, but you can also bundle functions together. So it's like more granular level of proxies. And also proxies can tell each other what kind of functions they have, right? That there is this interface for checking the functionality of each proxy. So it's like granular proxies with interoperability standards, communication standard, right?
Mm-hmm. Yeah, that's right. And another benefit, it's funny that some of the actual useful benefits of the diamond, like they weren't apparent until actually using it in projects. Then it became really what's really useful about the diamond. You find out from real experience, and that's I thought some other things would be useful, and they weren't useful.
Right. Exactly.
Yeah, and so another one of these things is that when you have a diamond, you have a lot of contract functionality, and it all falls under a single address. And I actually found that pretty useful, because if you have a lot of contract functionality and you have like 10 different addresses, well then, if you have user interfaces, you have to give your user interfaces 10 different addresses instead of just one. Or if
that's good.
Yeah. Or if there's another project that wants to integrate, on the contract level, wants to integrate with your project, you don't have to give them 10 addresses. You just give them one and say all the functionality you need is from this one address, and then you can provide your documentation. But I found that reducing the number of addresses you're working with contracts is useful for user interfaces and integration with other projects. So that's just something.
Yeah. That makes, so I get one address, and using that address I can get all the functionality in there. Makes sense. And it speeds up the development, but because you can update quickly, speeds up the interoperability between different dApps. And so Nick, please show us maybe on the screen, some dev tools. What do you use to program, and what is your dev stack? How does this look like right now? Because I think many people, they come into crypto and they're interested what other people in crypto are doing and what they're using. Because in traditional web development, everyone knows what everyone else is using. It's very, very common knowledge. In crypto, I feel that there is still a lot of things that people do their own way. So looking at your current dev flow, I see you use VS Code. So what else is special, would you say? Like if you are to build something, what is your process of deploying it and managing it and so forth?
Yeah, sure. So these days I use Hardhat, and let's see, I use Hardhat. I use, what else? Let's
use
see.
Brownie for deploying and things like
that? No, I just use Hardhat. I use Ethers.js for things. And really, I'm just trying to think what other useful tools that I use. I don't, that's just kind of what comes to mind. I could probably give you other information, but pretty standard stuff, I think, from with Hardhat. Let's see.
It's a lean setup, and it feels like Hardhat now has basically replaced Truffle to a big extent. Do you see that? Like Ethers is kind of replacing Web3.js, and Hardhat is replacing like Truffle and that ecosystem, like Ganache and all of the traditional ones. Do you agree on that?
Yeah, I mean, I haven't been paying attention to that. I just know that like I started with Truffle, and it seems like newer developers have started with Truffle. And I went to try with Aavegochi. I thought, well, look, this Hardhat looks interesting. I went to try it, and I don't know all the reasons why, but I liked it more than Truffle. I had some little issues with Truffle that were annoying. I didn't have with Hardhat, just like with compiling stuff, having everything work right. It just seemed more stable with Hardhat. I like the plugin architecture for Hardhat, how you can add more functionality that integrates with it. So yeah, and then yeah. So I guess that's that. Yeah, and then Ethers.js, I liked it a bit more than the Web3.js stuff. So yeah.
Nice. So what kind of project is next for you in terms of development? Because you've done QuickSwap, you've done Aavegochi. When you do a project, is there a lot of work to maintain it? Do you have to spend a lot of time maintaining the old ones, or is there another team? And can you move on? What's next for you?
Yeah. So when I design projects, like I do think about future maintenance, and like with the kind of cool thing about smart contracts is, once they're deployed, they can run, they can run forever. And in some cases, you don't have to like do anything like the Uniswap contracts, QuickSwap contracts with the swapping and liquidity pools. I mean, that stuff on the, you just got to make sure your user interface is working, and always we have to maintain that user interface, improve it. But it's really nice that like some of these contract stuff, they just run forever without maintenance. Once it's no bugs, no security problems, it's wonderful. So I think that with projects, I think a lot with how can I write this so that I'm doing less off-chain calls into the project, because that requires maintenance.
Right.
But how can I just keep this all on chain as far as the main core functionality and the important things? Keep those things on chain. But then like sometimes you want to do off-chain things, and it's worth the long-term maintenance. So I just consider that. With QuickSwap, the actual main developer is Sam Meep, and so he actually deployed a QuickSwap. I was working on some QuickSwap changes, but we didn't end up using them. End up using some contract changes. We just decided to go with Uniswap contracts unaltered. At the time, we didn't have any money. It was just faster. We didn't have we were it was, we already knew those contracts worked. But Sam Meep has really done a lot of the development for QuickSwap and the user interface and stuff like that. So but for me, Aavegotchi, I've done a lot of work on Aavegochi. Then we've hired more developers, more Solidity developers. So it's helped ease the more front-end developers. So it's helped ease the maintenance, but continuing to develop to do more. So that's kind of what's happened there.
And what is next? Do you want to do something on Polygon, Binance Chain, Moonbeam, Plasm? Because there are so many EVMs and there's so much opportunity in those platforms because they're new. So how do you view the space of blockchain and blockchain development in the next years?
Yeah, I really like Polygon. I'm interested in doing more on Polygon and Ethereum. I really like Ethereum. Interested in there. I've been helping people who are interested in the diamond and like projects that want some expert review on their diamond or help getting started. So like I've been kind of doing that on like a tech advisory basis with some projects. So I like helping people get started with that and seeing if it makes sense for them. As far as my own development, I'm not quite sure. There might be a QuickSwap version 2 that with some contract improvements and things. So I might work on that. That would be good. So that's kind of what I'm doing now. Mm-hmm.
So the way I see it is that EVM and Solidity, it's becoming kind of like HTML of finance, because it's not even running on Ethereum now in many cases. It's running on Polygon. The underlying engine is different, but the interface for developers is the same. So that's why I feel that if you don't support EVM, it's like you do a browser in the 90s and you don't support HTML. Yes, HTML is also new at that time. The adoption is new, but it's still that I think everyone will be running HTML, EVM, just like all browsers at the end of the day. Either you run HTML or it's not a browser. So how do you view that? Do you think that the native chains like Solana chain or Cardano, with their native like Rust on Solana and Plutus on Cardano, you think they will gain traction? Or if you are to speculate, because nobody knows, of course, but how do you think it will unfold?
Right. No, I agree with you that the EVM is just becoming more ubiquitous. It's it's becoming more like HTML that the platform people develop smart contracts on. I think as time goes on, there's more infrastructure support, more support for events, things like the graph, and I think those things will get better, and more tooling and more education that you're doing is huge, so people can learn. So I think as the EVM gets bigger and the support for it gets bigger, it's going to be harder to, and it's going to keep getting harder to build something else that that for smart contracts. And so I think that maybe there can be other platforms, and maybe they're better than the EVM, but they won't. I don't think they can't just be better. They have to be like enough. There has to be enough improvement to be worth abandoning the EVM. And I'm not, it's going to be like, a bunch of improvements. So I don't know if that's going to happen or not. I know I'm happy with working with the EVM stuff. I like that we're using the EVM. I can work on multiple blockchains.
Exactly.
So.
Perfect, Nick. Mm-hmm. So anything else you want to add before we round this intro up? Because we discussed what you've done, we've discussed the diamonds, we've discussed future of blockchain. What else do you think is interesting to the viewers?
I think no, I think that's good. I don't have anything off the top of my head. Appreciate that though.
Perfect. So, yeah, I love speaking to developers and hearing the thoughts and what people are building, how they're thinking. And guys, if you have some other developer you want us to interview, please write in the comment section and we would love to discuss. And that being said, Nick, thanks a lot for being here. And all of you who are watching, please go and follow Nick on Twitter. Link here, it's Mudge, Nick Mudge. So go and follow him. And thanks a lot, Nick, for being here and for participating in the show.
Thank you very much, Ivan. Thank everyone for watching.
Perfect, guys. Bye-bye.
Bye.